So as of today, Fable is going to be permanently included in the Anthropic plan, and which is a big sigh of relief for a lot of people, but a lot of people were pretty upset with Anthropic of this constant back and forth. Ultimately, with ChatGPT 5.6 Sol coming out and Kimi K3 that just got released, it forced Anthropic's hand. Now, a lot of people that I was speaking to had a lot of fears and anxieties about Fable leaving. They wanted to find a way to leverage it as much as they can before it left. And ultimately, I think that's the wrong way to go about this. If you're going to constantly rely on one provider, in this case Anthropic, but it could be any other one, you are always going to be at the whims and mercy of whatever they decide. They control your data, they control the pricing, and they control your access. So ultimately, it comes down to two things that are the most important when it comes to leveraging AI, whether it's for your business, for personal use, or for anything for that matter. And they're both things that are not going to be able to be determined by just one company. So the first thing that I want to talk about, and you can kind of see it on this screen here, and that is building a portable company brain. And again, if you don't necessarily run a company or you're a solopreneur or something like that, this can still apply. Again, it might look a little bit different, but the principles are going to stay the same. And so I'm going to show you exactly how to make one of these company brains from a high level overview. I'll do a future video down the road to get a little more granular. But after this video, you should have a really good idea of how a company brain could work. So the number one thing you have to think about is where does all the work happen? In other words, where is all the data and information coming from? So for my own company, it comes from Slack. I have 14 employees. We have a bunch of stuff going on in Slack, over 60 Slack channels, and that is going to be one of the main focal points and places that we get information. Another one for many people is going to be Gmail or any email provider that you use. WhatsApp can be another one, GitHub for any code repos. It can be phone calls. Again, your agents can connect directly to your iMessages now. Any type of meetings, which can either be via Granola or an app like that, or Zoom. Any kind of SaaS tools that you're connected to. Again, you'd need your API connections for that, or MCP, or any other external databases that you may use. So the biggest thing is this, right? When people used a second brain in the past, the issue was that it became almost a full-time job just to manage that brain, especially pre-AI. There were a bunch of content creators out there who use second brains, who taught second brains. I used one myself. I think it was called Pipelines and Vaults or something like that. I'm sure you could find it online, and it was fantastic. It was an incredible system. But the time that it took me to maintain that and make sure all the information stayed relevant and didn't become stale was almost a full-time job on its own. So it was just not realistic to create a brain like that and have it stay up to date. With AI and the different mechanisms I'm going to show you in this video, that is possible now. So when you find out where all your data comes from, all the work happens and everything, the second thing is you want to be able to connect it. Now, there are multiple ways that you can get that information connected. You can use WebSockets, webhooks, you can pull API calls. You can have, again, API calls being called with cron jobs and everything like that. And there's multiple ways to do that. So ultimately what happens is, let's say hypothetically you have some webhooks set up and maybe you pull it every 10 minutes or every 1 minute or 30 seconds to enrich some of those webhooks. What's going to happen is you're ingesting that information. This is raw information. That raw information, again, I'm using GBrain for this, which I'll explain a little bit more about later, but that raw information goes into Markdown files. Those Markdown files end up getting backed up. For some people, they get backed up into like an Obsidian vault. In my case, just a Git repo, simple Git repo has all my Markdown files in it, and you have the added benefit, of course, that you have version control that way. And what happens and what GBrain does then, and this is really cool, it takes all of those Markdown files, those raw Markdown files, and it then imports them into Supabase, but it doesn't just import the Markdown files. What it does is it imports the embeddings, the chunks, the metadata, and the graphs. Now, the question, of course, is what are all these things? So chunks, you can think of it like, let's say, again, I have a short-term rental company. Let's say you have a Markdown file about an entire property. It has a Q&A of everything you need to know about that property. A chunk might just be one section of just the pool heating, for example. So it'll chunk that one section about the pool heating, all the information there, and it will then put that into Supabase, and it will do the same thing for that entire Markdown file. It will chunk everything so that it's more digestible and relevant pieces. It will then create an embedding, and how you want to look at an embedding is imagine that it's almost like coordinates on a map. So if I say, for example, where is San Diego, it'll show that, and if I look for a particular street in San Diego, it will then look at coordinates near that street. it makes it easier for your LLM or your AI to retrieve those files. And then you have the metadata, which is pretty much, metadata can be anything from like the title of the markdown, the data entry time, maybe like even a quick description of what this markdown file is. You can kind of think of it, if you're in a library, instead of looking for the entire book, the metadata might be when was it published, who was the author, um, maybe what the category of the book is. Those would be good examples of metadata. And then finally, you have the graphs. So as GBrain does it, these graphs are essentially relational graphs. So they're able to backlink, just like how SEO works, different pieces of information together. So for example, let's go back to pool heating. I may have a property that has pool heating, and in that property, that may be backlinked to an overall policy as a company that we have for pool heating. So for example, it could give a price, and then as a company policy, we have to make sure that they have to pay for the entire stay, for example. And those two pieces will then be backlinked. And that'll be a relational database. And those sections essentially will be part of the knowledge graph. And then lastly, you have timelines, just to know how stale information is, how relevant, and how new it is. And so then you have something called zero entropy, is what I use, but it's essentially they're AI infrastructure companies that can create embeddings and re-rank evidence. And by re-ranking evidence, it will determine it by how new the evidence is, how often does it show up, does it seem more relevant for this particular query. And there's a lot of different providers that do that. Zero entropy is just the one I happen to use, but there's a lot of different ones. Even OpenAI has its own embedding system. And then essentially, you would query that database through any of the models that you want. It could be it can also just be you use a Hermes agent or Claude Code or anything like that. Anything that can call tools to get that information. And that is the rough structure of how a company brain starts to work in terms of ingesting information. Now, the second part that you want to look at here is, how does the knowledge become searchable? We kind of went over that just earlier, but I'll give an example. It says here, can we change the pricing, right? A customer might ask that. And then the AI or a human even could then query the database. And I may have already made a plan for that. That's in our database, but it can query the GBrain. It will then have all the structured markdown pages, which all the information is going to live on. That all gets chunked. And essentially, it's those chunked sections that are then embedded that will ultimately get queried, that either your LLM or whatever can find that data a lot quicker. So when does this become helpful more than anything else? If you are a solopreneur, or you only have 40 or 50 markdowns worth of material, you may not need an embedding system. You may not need chunks. You may not need the thing that GBrain specializes in. But if you start, I think we're somewhere around 4,500 markdowns for our company right now. If you're running a bigger company, or it's getting bigger, it's going to be way too hard for your LLM to try to route to the correct markdown file for just that particular thing. You're going to need incredibly complex routing rules for that. So GBrain kind of takes care of all that for you. So again, I kind of put a little bit here, the knowledge graph, but the next section then is how GBrain answers a question. Okay, so again, some of these are a little bit overlapping, but it will essentially intent classify. So that's trying to determine what exactly your question is. It then searches in parallel with a vector search, which is again the embeddings, which are those coordinates. So where in the coordinates would I find this? And then as a keyword search, for example, Acme company plus pricing, it will then look at any type of relationships, which is the graph traversal. And then you will have source and recency. And this is important because, let's say, for example, God forbid, you have mold in your property 8 months ago. That isn't necessarily relevant now if that got fixed. So if there's a question about mold, it can pull it from 8 months ago, and there might be new stuff about mold a month ago. They might be completely irrelevant for each other. So that's what this last step does ultimately. It then combines the results and ranks it, which again is part of what zero entropy does. And then you have a dedicated re-ranker after, which will then give you the most relevant answers. And again, this isn't a perfect system. These systems are going to get better along the way, but that is roughly how it works. And then you get your synthesized answer. You'll know exactly where the answer came from, what documents it pulled it from, and even the timelines of when all this was said and done. So that is a good high-level overview of how GBrain works and how a company brain could, in theory, work. Now, there's different people that do it different ways, but it's all going to be some form or fashion similar to this. I know Cerebras just, I think it was a day or two ago, published an article about how they did their company knowledge base and brain and everything like that. And it was kind of similar to this. They had some more advanced things that they did. For example, they ingested entire Slack threads and kind of kept them together too, which I think is interesting and something that I want to add. But I think based on this should give you somewhat of an overview of how a company brain could look like and how it could work. And a second brain that, most importantly, doesn't become a full-time job to try to manage yourself every time. Now, the second most important thing that you can do, aside from a company brain, is just agentifying your entire company. This is an absolute must. Now, what do I exactly mean by agentifying a company? Because everybody wants to use AI in their company, but what does that exactly mean? As I define it, and you kind of see it here, it's the creation of a virtual employee. Now, that is different than just an AI agent. That is different than just having, because again, a lot of people will make agents, they say, and really what it is it's a set of markdowns and instructions and tool calls in Claude Code, or it can live in Codex. And again, these are agentic platforms, but as I define it as a virtual employee, it means somebody that actually lives and acts where we're already at. In my case, that's Slack. We do so much in Slack. For you, it can be your Microsoft Teams, it can be something else that's similar, but it works right alongside your current employees already. And so, just to give a little difference of how these things can work, and again, many people are going to know this, but there's some that may not. Most people still use AI as a chatbot. They ask it a question, they get an answer. Maybe it can call tools if you're working in Codex and Claude Code. It returns text, and then you see what to do next. Whereas a virtual employee, it owns a defined responsibility. So it's watching continuously, it follows a defined role, you use approved tools, it takes actions and post receipts. Post receipts is a huge one, and it escalates to humans only if there's an exception. So how do I personally use this? So before I get to that, tool calling isn't automatically an employee. So here's how I look at it, right? I'm not going to create one overall agent that does everything. I'm going to create an agent that has one really, really, really small role that it's going to do really, really well, and that is very clearly defined. So I'm going to give you some examples now. Again, we have the company brain, which has all the shared context, the roles, procedures, memories, which then the Slack workplace, both humans and virtual employees can query that company brain, and the agents will be able to query the company brain so that they understand context. And then every single agent will have its own role. So for a short-term rental company, I have an agent that only handles everything pool heating operations wise. I have another one that does maintenance. So when there's guests that complain about maintenance issues, it creates a ticket, it follows up on the ticket, and again, it keeps the human in the loop. Another one that could be an analytics agent, pricing agents, inquiry agents, finance agents. Again, it's a very clearly defined and scoped job. So if I give you an example of the Poolie agent, for example, I'm going to scroll out here a little bit. This is our pool agent. So there's a couple of scenarios that could happen. A guest could check out. It then has to verify, and again, a verification is a huge, huge part of any kind of agent work. So a lot of times when people complain about hallucinations, it's usually because there's no verification in the loop. I'm sure as the models get better, and they are already, the hallucinations will either rarely happen or not happen at all, and verification loops in some form or fashion through sub-agents or parallel agents will happen automatically. It's not fully there yet, but it will be probably within months. But let's say that, I'll give you an example. A guest checks out. The agent would then verify the dates, the payment dates, and all that kind of stuff, the temperature of the equipment, and then it will apply the rules. So, for example, if a guest checks out by 10 a.m. and the pool heating is still on, that means go ahead and turn off the pool heating. That is a very clearly defined rule. The action, which I just explained, and then in Slack it will say what it did. This is all part of what's called a deterministic script or a deterministic workflow. And I want to be clear about this. The deterministic workflow, that existed before AI. It was just code, essentially, scripts and code. A lot of this stuff you could already have done pre-AI. It just happens to be a lot quicker to make it with AI, but you could have done it already. The part that's different is the latent side of it, or in other words, the judgment part. And so if there's ambiguity, or if there's something that requires judgment from the agent, that is what I call that last 10-20%, what the LLM does, and in this case, your agent through the LLM. And it could be an example of like there might be some ambiguity of like, you know, let's say a guest wanted pool heating. It verifies the facts, did they pay, it applies the rules, etc. But maybe the guest asked, and this is unusual, that they can only pay for pool heating 2 out of the 5 nights. And we may have some rules that say no, guests have to pay for every night because otherwise we can't control it and all that kind of stuff. But there's definitely been times when if it was a longer stay, we told the guest, sure, you can pay for 2 nights. So there's some level of judgment required to either accept or deny that. And that layer of judgment is going to be backed by guidelines and examples that we've done in the past. So I would show some examples of, look, the guest here stayed 14 nights, they paid a good rate, so we allowed them to do partial pool heating for only 4 or 5 nights. And because of that, again, it's not an always rule, but it's ambiguous. Those are areas when your agent can start to make decisions. But again, all of this is still backed by guidelines and examples. And guess what? That is no different than when you're training a real employee. Like how you train an AI agent is very similar to training a real life employee. You give them examples, you train them, you make them better over time. None of that changes. And then if there's a situation where it feels like it can't give a clear answer, which again, you're going to predefine this, like if you're unsure about this, this, and this, escalate it to a human. And that's where the human in the loop comes from. And again, you're still going to post receipts and all that. But that is a really great example of one clearly defined task for an agent, how it's able to do that task, when should it start doing judgment, and then what part should be deterministic. I think for agents that can be virtual employees, there's going to be a mix of it, but generally I've found anywhere between 65 to 80% of it is generally deterministic, and the last anywhere between 20 to 35% is probably latent judgment, which are backed by guidelines. I'll give one more quick example of an analytics agent. You can pull analytics through APIs from all your data sources. It then validates the analytics to make sure that there's no missing or duplicate or stale data. It then calculates everything. It compares it to benchmarks or thresholds. You can then classify if it's overperforming or underperforming. So think like an ad, you can put in there, we want to reach this much ROAS on an ad. And if it's doing under that, it will automatically classify. And then it will build an HTML, which has been predefined, to show you the data, or it can just live in a database that you've already had. I'm a big fan of generative UI, so building HTML links as needed. And that's all deterministic. The judgment part of this can be like, why did the performance change? What patterns? What should we text net? Like it can start to analyze why why the ads didn't perform as well as it thought. And again, that's again going to be based on previous examples, guidelines, goals, constraints, and company context. And then it can give you suggestions for prioritized improvements and give you an example of evidence of what we've done in the past or recommendations. And that's again where that latent space come in, that judgment comes in. So I say all this, and hopefully this video was helpful. It's my first one, so it's going to be definitely a little bit rough around the edges. But I have been using this kind of stuff in my company for months. It's nowhere near where I want it to be. It's a work in progress. I'm absolutely loving working with it. But I think the big lesson is don't rely on one company like Anthropic or OpenAI to provide your entire infrastructure, because they can remove things. Not only that, they can see all your data as well, which, so if there's SaaS companies, there's a chance that you might get eaten up by somebody like Anthropic at some point. And I think most importantly, the biggest moat that companies have are their tribal knowledge, their context, and their data. And so you want to be able to kind of guard that, be model agnostic, so you can plug and play any model you need to. And then you also have the added benefit when local AI gets to a point where it's good enough and cheap enough to run on consumer hardware. Realistically, 90 to 95% of the work that you do will run through local models that companies will own the hardware on. So you have those options. So don't be constrained on one company. The things that you can control are going to be your company context, and they're going to be the virtual employees that you use along the way. So hopefully you enjoyed this video. Like and subscribe above if you can, and I'll see you guys in the next video. Shoot me a comment on what you'd like to see next. Thanks.